All right. It's getting smaller. So I guess we have the last 3 lectures. Like, so do you have any questions about what we covered so far? So I'm not sure what the impression was when people voted on like learning about games, right? But the technical aspects we can look at is more along these lines, like the networking aspects of it, because like I mentioned, the artistic stuff does not belong in this particular class, right? As a side note, I noticed that Dish Network, the satellite provider, now they have one channel which has a camera pointing at Earth, which is live, and so it's their satellite. So it's I guess you're seeing the Earth from their vantage point. It's pretty nifty, if not kind of boring, because it's geostationary, so nothing is really changing. You see a bunch of clouds and you see the Earth. But I want to see what happens when you go behind the sun and all those things. So, if any of you have Dish Network, it's a weird channel, right? So the next topic, along the networking lines. So this one and the one we'll cover on Monday. Monday we'll look at cheating, are some of the very important stuff that the network game players would worry about, right? And again, you got the homework assignments, the last homework assignment in the project, right? For the project, I want you to just play some game to get a feel for how these things are. So it's not important what game you play. It has to be networked, it has to be multiplayer, and you have to be able to choose some of these things. And I think both the games, the Second Life and the other ones, are free for you to try, right? So the problem that they're trying to solve here is trying to figure out where the users are, where the servers are to be, and then trying to figure out, and hopefully you can do something about it. So the first paper is talking about where the users are and where the servers are. Second paper is talking about how you might go about figuring out what is the best server to choose. And the underlying theme here is the current schemes are not that good. So if you look at some of the games, if you remember the one that we demoed, right? You basically see what's the time between you and the server, and the problem here is a lot more complicated, right? So the complication here is there are a couple of different ways how distribution of sort of content happens. And one of they mentioned that a little bit. So the idea here is you as a human being is here, you as a human being is another person is here, right? And let's say you have a server. If you're doing your web documents, CDNs are the way to go. So essentially what happens is you replicate this content on multiple CDNs, other places, or use that for YouTube kind of stuff too. So if you go to access a certain object, the server might say, actually go and ask this person, and this person gives the stuff to you. So you find it sends you to the person who has the best network from you, right? So Google, for example, can send it to a Google appliance within our campus, so you get the good service. So the problem here is trying to figure out, for the server to figure out who has the best latency to you, right? And as long as it's reasonably accurate, you can do this stuff. So if two people are asking, so you can send this person off to this server, you to another server, and that's okay, because there's the content is the same, so hasn't changed, so you don't have to worry about making sure that this is the same content. It's the same content copied multiple times, so your problem really becomes how do you find the closest point to you, right? And even though it's the simplest case of the things we're going to see, it's not that trivial. There are companies like Akamai whose bread and butter is making sure that this distribution can happen and this distribution that you can be sent to the closest one, and it's not that trivial. And so the companies pay a lot of money to these companies to be able to do that, right? And so that's one such way. The other way is trying to figure out the problem that sort of this game is trying to figure out is you have to find a server who not only gives you, so the other application is the video chat, right? So if you want to do a video chat, let's say these two people are doing a video chat, and you're sending it through a server, right, not directly. So the problem here is let's assume that there is, you cannot have CDNs anymore because when you're doing a video chat, whatever you send has to be sent to the other person. So you have to find servers and the network characteristics. So suppose from here to here is cast A, here to here is cast B, and here to here is cast C, right? The way you would so how would you optimize it for a video chat system, right? So suppose you're doing a conference call video chat, and suppose somebody figures out the cost for here is one is A, one is B, one is C, right? And let's say we have another server which can mediate this stuff, and let's say this is, right? So the cost from each group member to that one server is A prime, C prime, B prime, and this one is A, B, C. How would you go about choosing the server which is good for the group? What are the sort of ways you can think of?
You just pick the server that has like the overall lowest, although you guys might have like a lot of people with very low time, but one guy with big time, so he will suffer. So you might want to look at something else to do that.
Yeah. So one of the ways you can do that is you want to find somebody which is uniformly sort of the same, right? Or the standard deviation is smallest, right? So you can make sure that you can choose one whose standard deviation is the lowest, or one whose average is the lowest, right? So you can compute stuff like means and standard deviations to figure out which way to go. So if the average for this is some, let's say it's n, and the average for this is n prime, you sort of look at these two. Then you look at the standard deviation for these two, and then you kind of make a judgment call, right? But what differentiates the video chat applications from this one is, suppose it turns out that this one, let's say, is 2 milliseconds or something, and C is like 3, and this one happens to be 100, right? Versus something here which is all 30, right? I'm guessing sort of the mean is sort of the same, right? Which one would you choose? For this all of them have the same sort of latency, and this one has one who's kind of off. The other two are very good, right? Again, it's subjective, but so what will happen if you choose this one? What do you think would happen? 30 is a small number, but assume that 30 actually matters to you, right? You can make it 300 just to make the problem interesting, right?
Then everyone will be unhappy.
Yeah, everyone would be unhappy, right? So it's not clear what happens if everybody's unhappy. I think if everybody's unhappy, you are as a group happier, right? Because everybody's slower, right? The annoying part is when one person has to talk and the other person cannot join it, right? So I think that this would actually be better than this one, just because when I talk something, when you want to chime, so if somebody is talking and the other person wants to answer, they can answer sort of within the same time as all their peers, right? So if you're doing a video chat of the classroom, then all of you have the same probability of reaching me. So it's slow, but everyone is suffering, right? Whereas in this one, it depends on who the 1,000 is, right? So if the 1,000 happens to be your boss in a company, then you probably don't want this stuff. But in other cases, it may be okay, right? So if it turns out that my latency, I'm doing a lecture, happens to be 20, and 1,000 happens to be for one of the participants who's not really wanting to interact, who just wants to sort of see what's going on. So this may be okay, right? So depending on what you're trying to do, you may prefer one or the other, right? But it's not very clear that you want to choose this or this, because I can see scenarios where this is good and this is good, right? So if the main person who's going to talk is having 1,000, and everybody else has 20 and 30, I think this will be awful, but we can come up with this stuff, right? So now we move on to video game, which is sort of the same as the video chat kind of thing. You're interactive, you're doing this interaction, right? So in a video game scenario, right, where these are 3 people playing, which one would you choose? What would happen if you choose something like this? with lots of variance. Actually, this is one of the things I'm asking in your homework project or assignment, right? What would happen with this one in a video game?
That guy with 1,000 probably just get frustrated and leave.
Yeah, the person who has 1,000 should practically leave, right? Because it's going to, they're so far off, so their motions would take so much time to go to the server and go to the other person's. So depending on how you're setting up the game, this person would be at a disadvantage, right? So in a video game, you really want to make sure that this happens, because it's not only the case that people, they get to speak or they get to go next, but they also at a disadvantage because they can't play, they can't shoot and all those things. I mean, these people, so essentially by having this stuff, you're prioritizing who gets to react faster. So this person can react faster, this person can react faster. This person takes a while for whatever they reacted to get to them, and whatever they do, it takes a while for them to get back. So you would like to avoid this sort of a thing, right? So that's the main goal of all the systems, which is you're trying to find something where, of course, you would like, if I ask you, what if I had another one which is 10, 10, 10 over 300, 300, 300? Obviously, this is the way to go, right? But in real scenarios, you might come up with cases where the different statistics may tell you different things. So the mean may be similar between these two, but the standard deviation and all those things may differ, right? There are other cases, I think, like you pointed out a little bit, which is the load on the servers, how loaded these are. So if you look at these games, they can only take in so many users. So there's too many users for a particular server, they may not like you. So the problem becomes a little bit more complicated, because now you have to find somebody who has the good network conditions to you, and a server which is not very loaded, because you expect them to sort of live on. And then another one which is not related to network at all, which is more application oriented, which is which one has the worlds that you want. So if you remember the demo, each game you can play with a different set of resources, with different set of worlds and stuff. So this server may have some virtual world, this may have some other virtual world. So you have to choose one of these things which gives you the world that you want. So if you're a bunch of friends trying to play this stuff, you have to look at all the servers to figure out, this server can support me, this one can support me, this one cannot support me, doesn't have the game that I want. Then you go around in different orders trying to figure out what's the load on the server, what's my ping time to all these things, and then come up with this with the global scheme, right? And so you expect something like this to have happened, and you end up with the good server. So the first paper actually was talking about what is really happening now, right? So if you really believe this is what you ought to be doing, then you expect people in the same geographical regions to be talking to the same server, right? So if I put up a game server at Notre Dame, I would expect that people in Notre Dame to be using my server, right? So if I turn it around, all my clients, I expect them to be in Notre Dame, or maybe in Chicago, this sort of area, right? I would expect that people from Japan won't be using my server because it's pretty far. Because unless all three players are in Japan and they just want to have a slow game, there's no reason for you to come halfway across, right? So the first paper, they're trying to look at from a server logs to see where the clients are, where the geographical things are. And it turns out it's not as nicely distributed as you would like, right? So let's look at some of the graphs. So in the first one, they were doing for a Counter-Strike, which is, I guess, a first-person shooting game, right? So again, this has multiple servers, and again, the problem with these systems are you don't have control over the logs from all the servers, right? So these folks, again, are in Portland. So there's a game company in Portland. So they got the logs from that particular company. So their view of the world goes from that server. So they can analyze the logs from that server, and you can connect to any different servers, right? So this one, it plots where the Counter-Strike servers are at I think somewhere in 2003, right? And so they plot the histogram of these servers, right? And most of these studies, you would find that most of the world, as far as computer science networking are concerned, exists here, exists here, and exists a little bit over here, right? The Japan, South Korea, and they're very, very big on video games, and to a little extent in Singapore kind of stuff. And then you have like a big blank here, and Africa doesn't exist on any networking stuff. You have Western Europe, then you have US, right? And if you look at South America, basically you have a little bit around Brazil, but for all practical purposes, the rest of the world doesn't exist, right? And you sort of see this stuff in this particular graph, and you see every other graph which shows this stuff. And it's kind of scary when you look at the connectivity to like Africa, right? Africa, I think, probably has like, for a while had like such a small network connection to it. Probably your DSL connection was better than what you see for Africa, right? So if you plot in longitude, you see this is the Portland West Coast area. You see the East Coast and most of this area, and this is Western Europe, not necessarily Africa. And you see the Japan and Koreas. And if you plot, they again plotted this as a CDF, right? So it's a kind of a weird CDF. So you have the map location on your x-axis, and it's a probability distribution on the y-axis. So you see lots of servers in the US and lots of them in Europe, and a little bit in Japan and Korea, right? And again, one of the reasons you find this stuff, I think I mentioned another class, right? US has lots of universities which have very, very high network connection, and students run this stuff. So they tend to subsidize these things more than, I suppose, other countries, right? One of the things you find is most of the US market is used to single pay, unlimited sort of content. Europe is more used to, you pay for DSL service, but there's a cap on how much bandwidth you use. So you tend not to run servers which can take unlimited amount of service, whereas in US, if you can run a server, you get to run a server kind of thing, right? So they pointed out on the latitude too, and as you expect, most of them happen in the northern hemisphere. So this is the, you're looking at, so essentially everything happens in the northern hemisphere, nothing in the southern hemisphere, right? If you have been to Australia, Australia is like really, really awful for network connectivity, right? I think for NetGames 07 when I was there, it seemed like T1, which is like 1.5 megabits per second, was what you expect from universities, and the rest of the country, the caps were so egregiously high that you don't want to run any servers kind of stuff, right? So you basically see that Australia doesn't exist that much. Most of them are here, right? So again, since there are multiple servers, right? So the first set of graphs showed where the servers were. So now you want to see where the clients are connecting to. So you're trying to see where the servers are connecting to the different servers, right? So again, since they didn't have all the logs from all the clients, so they only had the logs from this company, MSH-RMO, which is in Portland, right? So somebody's running a server, Counter-Strike server here, and they don't restrict who can connect to it. So the belief is, if you're running a server here, you want to see where your clients are coming from, right? So this is plotting for the particular server where the clients are coming from. So you see the dot around there, that's where your server is, and you're trying to see where the clients are coming from, right? And you notice that a lot of clients are coming from the West Coast, right? Because you get good network connectivity. So you see them from the West Coast, because that's the high y-axis. And you see some from East Coast, but you also see from Europe, you also see from Japan, Korea, that region, right? So essentially, even though you're running a server in Portland, you are having all these people connecting to you from halfway across the world, right? So two things can happen. Again, one of the examples we talked about, it could be that all your friends are in Japan who are trying to connect to somebody in Portland. So all of them have a slower network, so somehow they muddle through, right? Or there may be other reasons going on. Again, if you look at a CDF, about like 30 or 40% comes from the Portland area, but a whole bunch of stuff comes from all over the planet, right? And they also plotted where the major users are with time. So here now you have to look at the number of dots. The number of dots give a sense of where the clients are coming from. So starting from that graph, if you go A, B, C, D, E, F, in 4-hour chunks. So the first one is midnight to 4 a.m., 4 a.m. to 8 a.m., and so on and so forth, right? And you can see the sort of the diurnal trend that you expect, right? So midnight, so this is specific time. So midnight 3 to 4 a.m. for them would be pretty late for East Coast. So there's not much activity in the US, but there's more activity in Europe, right? And as you see during the day, the pattern shifts back and forth, right? So and since the countries are not evenly distributed along the globe, because you have the Pacific and all the different oceans, you sort of get the local peaks, and then you don't get any action kind of stuff, right? So this means that from a server creator perspective, right, you're getting all these clients from all over the planet, and you really don't know why they're coming to you at some time. And it could be the case that, for example, 8 p.m. to midnight, right, there are not that much happening in the rest of the world. So so those sort of things may drive why people are coming towards you, right? So the conjecture was there are a lot of reasons why this may be happening. So all the logs tell them is basically where the clients are coming from. They don't know why it's happening, right? So a good reason might be that there's no correlation between geography and the network latency, right? And it is true for a large extent. Like I mentioned before, if you go in a very fine-grained state, just because we both live across the street in South Bend means nothing, because from Notre Dame you have to go to Chicago and come back, and if you're using Comcast, you may be connected to directly, right? So in that sense, it may not matter much, but in a broader sense, it does matter, right? So if you live in Japan, you are going to be slow because you're pretty far off, and the speed of light issues come in, right? So that may be a factor. The other factor may be that the servers themselves may be slow, right? So the delay that you're going to see is if you are a client, if you have two clients, and you can choose a server, right? So what you're trying to do is, I make a move, I create a little update, like I shot somebody or something. I send it to this server, and it has to send it to all the people, right? So let's assume that the delay here is D1 and delay here is D2, right? So the overall delay it takes for my action to get to that person is D1 plus D2, right? Plus the processing at the server, right? Let's say processing at the server, right? So it may take some time to send this across. So maybe this dominates, right? If this happens to be pretty high, then it doesn't make sense to optimize on this one, because all you're concerned is the time for processing the stuff, right? So maybe that's why it's happening. Or the third reason is maybe the server selection algorithms are broken, right? And maybe the other reason is the number of servers is the one that, so the number of servers in a server may affect the processing cost. So users may be choosing something based on the number of servers. The last one is maybe there's not that many servers in overseas, so they're forced to come here, right? Their data does not show any of those stuff. This is sort of, you don't go by the data, you have to get a sense of what happens from the user stuff, right? So what do you think would be happening? Which one do you think is the most important reason of why? Unfortunately, many of you don't seem to play these kind of games, but if you were to play this game, multi-user video games, and it turns out that you're using servers that you shouldn't have used, right? What would be your, yeah?
I know sometimes with some games that I've looked at, if only there are maybe no people on the server, or like one or two won't be as fun, so you might end up choosing a server with a higher ping just because there's actually people to play with. Mm-hmm. So it seems like it could be a logical reason. They just don't have.
So you're saying the opposite, that you choose a server which has more users.
Like, yeah, you don't want one that has like a ton of people, but you do want enough people to play. So like, if people are going to America because that's where all the people who play the game is, then I think that would make sense.
Okay. Oh, okay, that's another reason, right? So, okay, that's where the actual world is, right? Okay, so that's the another reason is the better worlds are you go to play where the better worlds are. I mean, you also add that into the picture, right? What others think of what might be the reason why people are doing this stuff? How many want to believe that the server selection mechanisms on popular games are broken? I'll put it the other way, right? I think the other way I would have phrased it is there is no penalty from the users for running a crappy algorithm, right? So servers don't bother to, or the applications don't bother to do a better job, right? You can say that we have crappy algorithms, but I think the reason could be that if no one seems to care, then you use the simplest algorithm you can think of, right? So one of the things I want you to try is like, for a homework project, try one of these things to figure out how it happens. But at least for the games that we played, it just gives you the ping time from you to the server, right? So the way we should have done the stuff, and you might have seen me do that, right? When you had the 2 laptops, right? I had to go in it lists a number of servers, like 100 or so servers, right? And I have to choose one of the server. Then I have to walk over and then choose the same server on the other end, right? So in the real game case, I would have had a video chat or audio chat or on the telephone with your friends. So if you have a bunch of friends, and each one of you is looking at a list of like servers, right? And it tells you how much ping each server is seeing. So one of you you have to converge on what server to choose based on what you're seeing, right? So you'll have to look at the server and say, oh, I think I like this, this particular server very good, so I'm going to join. So you have to tell that to your friends, so they join, and then you all pick a server, right? So you don't actually have the server telling you what to do. You as a bunch of clients figure out how to join, right? So it's not clear exactly what the penalties are for not helping you choose this stuff, but otherwise, if you don't choose the right things, you should suffer, right? And that's one of the things I was trying to do on the demo that you may be able to find, where if you have one person whose latency is very good, the other person which is kind of bad, what kind of advantage you can get, right? Because I think that's a much more important driver than anything else, right? So if you join with a bunch of friends, and it turns out they suddenly figure out that you are having an excellent game, and they're not, and they couldn't figure out any other reason except the server choice, then you would do something about it, right? So that's the first one. And they had all these different data, and they're trying to figure out what it means. So the next paper was trying to figure out how to help you do these things, and it uses some of the things we talked about, right? This is the NetGames stuff on the next year. Okay, so again, it's a different paper. So here they're trying to motivate you again, like what I was saying, why it's important to figure out which server to choose, right? Many applications may not give you control over selecting the server, but I think most of the games do give this control, especially for certain games where the companies host the server, so you have to choose the right set of things. There are other games, like including the one that we were playing the other day, where you can host a game. So you can also figure out who should host this game, sort of thing. So it's not just a standard set of servers. It's also these set of servers which come online every time you start to play. And even some other games let you choose who the server is. And so essentially the players join these kind of things. And again, there are other factors which affect these things going beyond the stuff. One is the server version. You don't want to talk to, you cannot talk to the wrong server, right? You want to make sure that it has all the add-on and the virtual worlds and stuff, and you have to make sure that the server is not too full. The sort of things that it's not necessarily programmed. I mean, you just may not like this particular server because in the past you played and you didn't like the world or something. So you have to consider those, right? So even if you choose all the stuff, I mean, the latency can vary a lot. I mean, it can go from 50 to 1,000, and that's a significant enough difference that somebody has advantage, right? So and there's been lots of works which show that the latency does matter. I mean, this NetGames this is practically one of the chronic set of papers which show that on all these games, how exactly it matters, right? But intuitively, it matters because I point at somebody and I shoot, and if the latency is high enough, you would have moved and I wouldn't have known, right? So your experience depends on the latency, right? So from a research perspective, you want to know how exactly it does this stuff, because the fear is if normal users may not truly understand the nature of how these latencies are added up. So if you join a game and you're always losing because you chose the wrong server and your latency to the other game is too long, right? Then again, you run into the problem that we tried to address in the last lecture, which is you may leave the system, right? You may leave the system by not paying somebody the amount of money that they wanted. You may lose customers. So as a game developer, you want to make sure that this is all solved, because you want the users to have a fair chance in beating somebody, right? And the fairness, one of them is a server selection, the other one is the one cheating problem we'll see on Monday, right? And again, you may realize that some of you may realize that this was actually done at IBM Research, Hawthorne, New York. And again, the reason why IBM was involved with all the stuff is they wanted to run these game servers. They wanted to figure out whether their data center machines can run servers. So they wanted to figure out how the load changes and how the users are, and so on and so forth. And that's their motivation. So in general, selection of a good server who's close to all of you is important, right? Yeah, and again, so it gets complicated when people are in geographically different locations, and you want to try to find a server which is good enough for all of you. If they're all in the same location, it's no big deal. In the actual demo that we did, one of the machines was acting as a server. So in that sense, both of you are sort of fair because you're just playing locally. But if you're playing on a remote site, this is a big deal, right? Actually, I saw a news article on Yahoo News yesterday citing some kids who play more than 12 hours as addicted, right? And they have like 25% of the kids, I believe, in Korea are addicted, right? So we're talking about people who play more than 12 hours a day, right? And I'm surprised that none of you play video games enough to worry about these sort of issues, right? So the challenge here is to try to find a server which is good enough for sort of all of you, right? There are a number of reasons why this becomes a challenge, because the way these systems are done, I can bring up a game server and I can have people connect to me, right? So if the system operated with one central controller which had absolute knowledge of everything, maybe we can perform different. What I mean is, suppose the server knows that there is one Oracle server, right? It knows that there are 3 servers here, right? It knows that if you have a bunch of clients, it knows right? It knows the cost from any client to any server, right? Which is called the all pairs. It knows the cost of all pairs of client to server cost, right? Then it can say, if you start a game, you can say U3 have started. So based on U3, the clients, and since I know all pair cost, I can tell you that you should choose the server. So I send you to all of you to that particular server, right? Sort of what you would expect that U2 to be doing for a single U, whereas you can do sort of these things, right? But there is no such Oracle server here because anybody can run these servers by themselves. So I can start a server in my DOM or in your laptop, wherever you are. So these servers are completely disjoint, and you don't have this all pairs cost, right? All you might know is a ping cost from here to here, from you to one server, or maybe you can do a ping from you to all the servers. But the servers don't really know all the costs. So that's one of the problems you have to solve, which is how does everybody know the cost of everybody to find out what the optimal cost is, right? So you have to find. So once you know this all pair cost, then you can sort of optimize it to figure out who should be the one to go. Right now, all you know is from each node. So right now, all you know is like this node. This user knows this cost, and this cost, and this user knows this cost and this cost and this cost, and so on. But they don't know what's the cost. So they may find that from here to here, this is the best way to go, but they don't know how the cost is for the different users, right? And you're trying to do this in a distributed fashion. So the state of the art in server selection, so you pick one of the servers, and then you do a ping, and many of the games tell you what the ping value is, and so you know based on the ping value what ping value you choose. And so if you only have, if it's a one-player game, it's trivial. You do a ping or something, then you figure out what the different servers are. You try to figure out what the load is. You're trying to figure out what games are there. You connect to the one that sort of solves all your concerns because you're the only one. So when you're doing a multiplayer game, you have to figure out what is good for you. So you have to have a offline mechanism, like a telephone call or something, to figure out what happens. So you proceed to find out what's good for you, and then you sort of explain this to you with your friends, and then you sort of come up with a list. So in the example we looked at, show like 140 or so servers. So you're trying to sort what is the best among all your people. So you sort of say, I have these sort of servers that looks good, and then your friend says something, and then you say something. Then you iterate through this stuff to figure out what is the best server to go. It's time consuming and error prone and so on. And so one reason that you see people randomly picking something is if it looks sort of good enough for all of you, you may pick it up, and it might turn out that it's on another continent, but it's sort of the nature of how these things are worked. So they did something which is rather trivial, right? So how would you solve this problem? How would you solve this problem of, right now, all you know is from your view, what is the ping time to all the other ones, right? How could you solve this, right? So the way to solve this is I need to know the cost of, I need to know all pairs, right? So I need to know what's the cost of ping time from here to all the different servers, right? Which I don't really get, right? So the way they solve the problem is essentially I become sort of the chooser or server. I tell this one to do something for me and send me the results, right? So I choose a server, a set of servers. Then I send some command to this one to say, you run this command, and then you tell me what your time is, right? Or if you can connect, maybe you cannot connect to this particular server from your side. So I send some query to you. You run this program, and then you send your data back to me. I send the same thing to you. You send the stuff back to me. You send this stuff back to me. Then I put everything together and come up with the right answer, right? So you figure out what the right thing to do, and there's the program called QStat, which essentially tells you to figure out what's the cost to a particular server, and then you can also specify what kind of a world. So you can say from your location, can you do this stuff? You run these things and come back, and so this, one of them becomes the host, and it essentially gets all the data from the. So I send the command to each of the. So I being the host send it off to the other of these things, and they run the stuff for me, and then they return the stuff back, and based on the stuff, and then we connect to the things, right? Do you like this solution? If four of us want to join, so basically I become the chooser. I pick one server. I send some command to your client to say, I picked these servers. You do a ping from your site, find out what the statistics are, and then send it back to me. So I collect all the stuff, and I figure out what is the best solution, and then I send it back to you saying, now you should go with this one, and then you proceed, right? Would this be a good solution? This is the solution that they proposed in that particular paper, right? What would be a concern if you were to do this for your game? You said playing with a bunch of people. I'm asking along the lines of like security and privacy kind of concerns, right? Yeah.
Well, they're sending you a command to run, so you can theoretically maliciously modify that and run arbitrary things.
Mm-hmm. Yeah, so you want to make sure that you sort of understand what commands they're sending, right? So you want to restrict the set of commands. If you want this to be automated, right, which is sort of the goal, right? I mean, you don't want to send this to some human being kind of thing, right? So you want to have like a restricted set of things that I can send, right? I don't want them to run anything. I just want them to run some restricted set of stuff. So, for example, I don't know exactly what the QStat does. So I can say your client knows the program called QStat, so it basically run that and then send that response back to you, right? But in general, this is the privacy issues goes sort of beyond that too, right? So I can use this to do a distributed denial of service attack, right? So if I can sort of trick all the Counter-Strike servers to send a ping to you, you may think it's good because all you're doing is you're just doing a ping to the server. You don't realize that I did this to the 2 million Counter-Strike clients, which all tried to ping him, which will bring him down, but you all think that it's okay, sort of thing, right? So you have that sort of issue. And it becomes sort of tricky because you cannot validate the server, right? You can validate that you're only running QStat, but you cannot validate that you're only pinging the official servers because there's none, right? It ought to be able to run with any server. So if you bring up a new server, you want these things to sort of attack this machine, and you sort of expect these things to be sort of good. And it doesn't quite sort of scale too. It doesn't kind of learn anything from this model, right? Meaning like, so if you again join another group, you'll do the same sort of pinging. You don't learn from anything. You don't relearn from anything. Even if you just did this sort of ping 5 minutes back, if a new game starts, you start all over again. So you create a lot more messages and stuff. But hopefully this will give you a better set of results than you iterating through on the screen, right? Hopefully this is the first step, and hopefully you'll find better solutions, right? So instead, so I'm going to have to pick you because you're the only one who seems to have played this games, right? So what do have you played like commercial, like big games? One of the things I saw was like the Madden, NFL kind of things, right? Which is much more popular than fringe games, right? What do they? How does it happen now? I mean, this is slightly older paper, right? 05, right? Are things better now, or do you?
In terms of what exactly?
In terms of like server selection.
I mean, things seem to be pretty decent, yeah. Occasionally I'll get booted off, but for the most part, there seems to be games that I've played, pretty good latency, not a lot of issues with lag and things.
Mm-hmm. So one of the I'm not sure if you guys listened to the colloquium yesterday. I had to listen. I couldn't hear it. Did anyone see that colloquium? So one of the things that if you talk to the game developers, they're awfully unaware of networking, right? They basically sort of picked up some networking programming book on how to create UDP and maybe ping and stuff, and that's all they know, right? So, like for example, they don't understand the triangular inequality, right? Just because my ping time to you is here, my ping time to this is here, doesn't say anything about the ping time between those two, right? They sort of, they say something like, oh, if I can ping the time from me to this server, I can ping the time from me to this server, then I can deduce the time between those two servers. No, you can't, right? The way they solve this problem for the most part is they assume the network is sort of a black box. They assume that the network is unpredictable. So they've tried to push more of the computation to the game itself and not worry so much about what happens on the network, right? And so essentially they're making the programs more complicated, or they're making the program not so precise, right? And there's another paper from the same authors. So what I mean is you try not to have weapons which are highly accurate and highly depend on the time, right? So you don't want, so if you're doing a first-person shooting game, you don't want to do a, shooting from 2 miles or so, right? Sharp shooting, right? You don't want sharp shooting from 2 miles away on some target which is pretty far off kind of thing, because any little error gets amplified. You'd rather have like a blunter weapon kind of thing. So it's not really important how the latency sort of works, right? Which means that I don't actually try to shoot one person. If I shoot, I basically take out this whole classroom kind of thing, right? So that solves the problem because I don't have to be very precise because he can't run away from that kind of stuff. It's not like the whole classroom kind of thing, but essentially the idea is you don't try to go for pinpoint accuracy. And that's sort of a shame because they're doing this because they don't understand networking enough. But it doesn't have to be as bad as what they make it out to be. And in some sense, you can do a little bit better than that, right? What we haven't considered here is what happens if things change, right? All this problem tells you who's the best server to connect, but networking conditions keep changing. So if you're playing a game for an hour, who knows what happens after the hour, who's the best game server? But that's even a harder problem. So anyway, you look at this stuff. The selection algorithm is simple. You throw out all the servers which are like not answering and stuff like that. Trivially, you can throw them out, and then you pick up the best server based on some parameter. And again, like the example I gave you here, you have a bunch of servers. You try to figure out what is the best way to go. So you should look at the average and standard deviation. You try to figure out which is the way to go, right? And so in this particular case, the average, that's the smallest in terms of average. This is the largest in terms of average. In terms of standard deviation, this is the smallest, and that's the largest, right? So if you look at this stuff, this one person is off. They're compared to the rest of them. Here, everybody's sort of the same, and depending on a particular game, you sort of select one or the other, whether that's okay or this is okay, and then off you go, right? So you have to define a notion of what is fairness and how you perceive these different games. And they evaluated the stuff, and again depends on the particular evaluation scenarios, right? So if the way to evaluate this stuff would be to find nodes where the sort of thing makes a big difference, right? So if you're playing with a game with people, all your friends who happen to be in Indiana, right? This sort of algorithm need not be that accurate. It has to be more accurate. So you don't actually see a big deal. Unless you use something like this. One person was in Netherlands, one person was in Massachusetts, one person was in Malaysia, one person was in North Carolina. So they're practically sort of all over the place except for the A and C. So there's a clear solution of where you want to go. But if you look at the ping times, it's all over the place because if you've done any sort of pings, right? Pings are not a very accurate way of figuring out the times because there's a lot of network variability. Right? So each cross is for a different player, and they're seeing sort of different times. It need not be this bad, but the exam. So if you have a player who's is in either Indiana, Illinois, like this mid kind of thing, you don't notice this much of variation, but you're sort of looking across the planet. They did a CDF, and essentially it's sort of the average ping time is what you matter, and there's a clear difference between the different games. And again, it's a subjective kind of thing. So if you do a manually figuring out what it is, it takes a while. But automated approach is best, as you would suspect, because it essentially collects all the data and figures out what to do. So they come up with the answer in 30 seconds, right? But not that surprising, because So the real complication here is I need to send this command to you to make you run this stuff and then get back. And it's with programming 101 or something to figure out, I have 4 values trying to find out one of the best average or what have you, the standard deviation, all those things, right? That's what they were showing. So anyway, so they have their proof of concept, and this is the little way to go. But the challenge here is trying to see how far it goes, and that's one of the things that I was asking you. And one of the things that I would like for you to look in the newer games, because these are fairly old, to see how the gaming industry is kind of proceeding with this stuff. Because a lot of people are excited about these sort of network games, and the question is how should the server selection happen, right? Anyway, so that's all that paper has, right? So if NetGames is a good conference to see what happens for this kind of a research. There's a lot of papers which are looking at these things, and these are one of the most popular topics that people try to investigate: how to find these good servers and so on, right? So we'll continue on Monday with a look at how to prevent cheating, which is again very, very important, because people don't like to be cheated. So if you get cheated, then you tend to lose, right? So if you're playing a game with a bunch of friends, and if somebody is cheating, then they'll always tend to win, in which case you always tend to lose. So if you lose often, you won't pay the subscription fee, which is what we care about, right? So we want to prevent cheating from that perspective. I'll see you on Monday.